Hello, this is the week 5 recording. We're going to be going over lesson 8, which is proportional relationships and tables. Okay, so here's a warm-up question. I included this because you have one very similar to it on your exam, so I wanted to go over it so that way it'll be the second time you see it instead of the first. So a recipe that you're following uses 3 ingredients that can be mixed together. So you need 1/3 a cup of flour for every 1/3 of a teaspoon of baking soda and every 1/5 of a teaspoon of salt. How many teaspoons of salt or teaspoons of salt do I need per 1 teaspoon of baking soda? Okay, so we're talking about teaspoons of salt. Okay, so that's this. And we're talking about teaspoons of baking soda. So that's this right here. Okay, so for every 1/3 of baking soda, okay, we need 1/5 of a teaspoon of salt. Okay, so I want to know how much salt do I need if I am using 1 teaspoon of baking soda. So since I'm using 1 teaspoon of baking soda, the 1 goes on top, okay, because your units always have to line up. So up top I have baking soda, which means on the bottom I need to have salt. So I don't know how much salt I need. So to go from 1/3 to 1, remember you always divide it by itself. So it's 1/3 divided by 1/3 gives me 1. So that means I also need to divide this bottom by 1/3. Okay, so when I do my math over here, I have 1/5 divided by 1/3. So here I need to copy dot flip. So I'm copying my first fraction, changing division to multiplication, and flipping this last one, which is, oops, 3 over, let me erase that, sorry. 3 over 1. Okay, remember anytime you're dividing with fractions, you need to change it to where you're multiplying by the reciprocal. Okay, so I'm multiplying by the reciprocal. The reciprocal is your fraction flipped. Now since I have multiplication, I can multiply straight across the top, straight across the bottom. So I get 3 over 5. Which means that for every 1 teaspoon of baking soda, you need 3/5 teaspoons of salt. So this is 3 over 5 teaspoons of salt. Okay. So yes, it gave us this 1/3 cup of flour, but since that wasn't a part of the question, we're actually not even using that. So that's just information they give us to kind of try and throw us off. Oops, sorry. All right, so lesson intentions. I'll be able to determine unit rates from diagrams and tables, be able to determine if the relationship is proportional, be able to find the unit rate to find missing values, and be able to determine which is a better deal. So kind of similar to last week, we're working with unit rates, but now instead of with graphs, we're going to be doing it with diagrams and tables. Okay, so first I want to go over how you read a table. Okay, now if you remember from last week, I said that your unit rate is always y over x. Okay, that is still true. When you're looking at a table, okay, your first column is your x, your second column is your y. Okay, think about the alphabet. When you go all the way to the end, it's X, Y, Z, right? So it's in alphabetical order. So first column is always X. Your second column is always going to be Y. Okay? And then, so each of these numbers that are next to each other, like here's a 3 and here's a 6. These two are a pair, which means when I write my coordinate pair for this, remember my x comes first, so I have 3, comma, 6. Okay, remember it's x, comma, y. So I'll do it one more time. Here's the second pair. Okay, I have 5 and 10. Remember your x comes first, x is 5. My y comes second, my y is 10. Okay, so if I wanted to write this as a ratio, remember it's y over x, so I'd write 10 over 5. Okay, Now, sometimes they will give you tables that look like this. This one is labeled for us X and Y. You read a book from left to right, okay, so X comes first, and you also read a book from top to bottom, so X comes first. Okay, always remember when you're looking at a table, your X value comes first, whether it's on top or it's on the left. Okay, so think about reading a book, X comes first. When I see this table, I read this number first, so that's X. When I'm looking at this vertical table, X is on top, so X is on top, Y is on bottom. Now, when you're creating rates from these type of tables, it is so important that you remember that it is Y over X. Okay, because if you notice, they're flipped. It's upside down. So when I take this 4 and 12 and I write this as my ratio, it should actually be 12 over 4. Okay, this is the most common mistake that I see students make. So make sure that you remember it's always Y over X, and when you have a table like this, it's flipped from what you see. Okay, we'll do problems and examples with it, so it won't be the only time you see it, but just always remember it's Y over X. Remember, X always comes first. Okay, so here is our first example. It's asking, what is the constant of proportionality? I said this last week, but constant of proportionality is just another way of them asking for unit rate. Okay, your constant of proportionality is your Y over X. Anytime you hear constant of proportionality, it's just Y over X. So our first column here, remember this is our X, which means this is our Y. So if I were to write my X comma Y for this first pair right here, I would have 5 comma 30. Okay, so I have Y over X. So when I look at this table, I have 30 over 5. And I can simplify this, right? 30 divided by 5 is 6. So that means I can read 6 pages every 1 minute. Now, where I got pages and minutes from is my table. My Y is my number of pages read, and my X is time spent reading in minutes. So I can read 6 pages per minute. Speedy reader. It doesn't matter which of these pairs you choose in this table, you'll get the same answer regardless. So let's try one with the second one. Okay, so 10 and 60. I'll do it down here. I have 10 comma 60. When I write it as Y over X, I have 60 over 10, and I still get 6. So this is still 6 pages per 1 minute. Okay. Let's try it again. This time we have some decimals. It's okay. With decimals, remember on any of these problems, I highly encourage you to use a calculator to make it easier on yourself. Okay. This says that a table is proportional if every pair has the same unit rate. Okay, so this question is different. It's asking us, is the following table proportional? When you are checking, you have to check every single pair. You cannot check 2 and go, oh, well, they're good, so that third one must. You need to make sure that you check all 3. Okay, exams love to throw the last one, not be proportional, just because some students skip it. Okay, check all 3. So what I mean by that is this. Let's do our first XY, right? I have 2 comma 5. So I have 5 over 2. When I divide those, I get 250. Okay, now let's move on to our second. I have 3 comma 750. So I have 7.5 over 3. I'm going to double check this one on my calculator. 7.5 divided by 3, I get 250. Now I have to do the last one too. Remember, you always check all 3. Okay, I have 5 comma 1250. So I have 12.5 over 5. In my calculator, 12.5 divided by 5 gives me 250. So notice how all 3 of our unit rates, right? I have this one, and this one. All 3 of our unit rates are the same, which means yes, this table is proportional. because, okay, because all my unit rates are the same. So because my unit rates are the same. Okay, you have to check all of them. I can't stress that enough. So if you're asked a question and it says, is the following table proportional? You have to go through and check every single one to make sure that when you divide it, you get the same number every time. If you get one that's not the same, then it is not proportional. Okay, so for it to be proportional, every pair has to be the same. Okay, let's do another example. I'll switch my color back to blue. Okay, so is the following table proportional? Remember, let's do this first pair here. I have 3, 650. So that means I have 6.5 over 3. My calculator, I'm going to do 6.5 divided by 3. Also remember, when you're typing this into your calculator, you go from top to bottom. So 6.5 divided by 3. And I get 2.16 repeating. Okay, let's try the second one. I have 10, 13.50. So when I write that as my rate, my y goes on top, so 13.5 all over 10. 13.5 divided by 10, type it into your calculator. And here I get 1.35. So since when I'm solving my rates here, these two already do not equal each other, right? 2.16 repeating is not equal to 1.35, so I don't even have to check this last one because I already know that this table is not proportional. So this table is not proportional because my unit rates are not the same. Are not the same. Okay, so for a table to be proportional, the unit rates have to be the same. So it's not proportional. All right, one more of these. Go back to blue. Is the following table proportional? Let's go through and double check them. So I have 5, 8.75. So my y goes on top, 8.75. My x goes on bottom, which is my 5. Remember, it's x, y. My calculator, I'm going to type 8.75 divided by 5. Oops, I typed it in wrong. And I hear, sorry, I get $1.75. Okay, so let's check this next one. 12, 21. So I have 21 over 12. 21 divided by 12. I get 175 again. And our last one. Let's double check the last one to see if it's the same here. So I have 25, 43.75. So y goes on top, which is my 43.75, all over my 25, which is my x. So 43.75 divided by 25. And I also get $1.75. So is the following table proportional? 175, 175, and 175. Yes, it is proportional because my unit rates are all the same. Okay, so yes, it is proportional. Now, I want to go over one thing with you on this example. Okay, so this first one I had, my unit rate was $1.75. Okay, if I take my unit rate and multiply it to my x coordinate, okay, if I take my unit rate and multiply it to my x coordinate, so my 175, if I multiply that by 12, let's see what I get. 1.75 times 12. I get 21, which is my y. For the bottom one, let's try this one. If I take 175 and multiply it by my x, which is 25. 1.75 times 25, I get 43.75, which is my y. So if you have a unit rate and you multiply it by your x coordinate, you should get your y. Okay, that's another way to kind of go in and double check it. We're going to use this method to solve a different type of problem later, but I wanted to show it to you now so you could see that there's multiple ways of solving this. If you were to take 1.75 and multiply it by 12 and you did not get 21, then that means that the table is not proportional. Okay. The first letter of the quiz code for this week is C as in cat. C as in cat. Okay. Proportional relationships with diagrams. So this is the same process as the tables. It just looks a little bit different. Okay, in lesson 8 in the checkpoint and in your workbooks, you're going to be asked to work with diagrams. On your exam, however, there won't be any. On your exam, you're just going to have tables. But I like the diagrams because I think it's kind of sometimes easier, a little bit easier to see or just visualize what is happening. So here I have this diagram talking about cost of apples. Okay, if I look at this first one here, I have 1, 2, 3 apples for $2.67. On this one, I have 1, 2, 3, 4, 5 apples for $4.45. And then this last one, I have 1, 2, 3, 4, 5, 6, 7. Nope, 8 apples for $7.12. Remember, in my lesson 6 video I sent out at the beginning of last week, I believe, I said whenever you have a ratio, money always goes on top. Okay, so for our first one, I have $2.67 for every 3 apples. Okay, let's divide that. So 2.67 divided by 3. When I divide this, I get 0.89. So that means I'm paying 89 cents for each apple. Okay, let's do the second one. This is 5 apples for $4.45. Okay, for 5 apples. So let's divide it. Divided by 5, which means that this is also 89 cents per apple. Now let's double check that last one before we say yes, it is. Last one is $7.12 for every 1, 2, 3, 4, 5, 6, 7, 8. I just wanted to double count. 8. So 7.12 divided by 8. And I also get 89 cents. So since all 3 of my unit rates here are the same, that means yes, this table is proportional. Okay, hopefully you're kind of seeing the patterns and how you figure out whether or not a table or a diagram is proportional. Remember, for it to be proportional, all your unit rates have to be the same. Okay, here's another one. This diagram is a little bit different. So this is talking about how pricing, right? So this is like our first one, second one, and our third one. And it's for 1 hour of laser tag and 2 hours of laser tag. So this first half rhombus here, it's just a triangle because it's half of it. So that means that I can pay $8.50. Remember, money always goes on top for 1/2 of an hour. Okay. Now, when you're doing 850 divided by 1/2, 1/2 as a decimal is 0.5. Okay, so you can type this into your calculator as 8.5 divided by 0.5. And when you do this, you get 17. Okay, so this tells me that I'm paying $17 for 1 hour if I pay for each half an hour. Now let's do the second one here, this one. I'm paying $12 for 1 hour. Well, 12 over 1 is just 12, right? If I'm paying with one choice $17 per hour and another choice $12 per hour, those unit rates are not the same, right? Because 17 does not equal 12. So this diagram is not proportional. Okay. Second letter of the quiz code is H as in happy. H as in happy. So you should have CH. Finding missing values. Okay, here, this is where what I talked about with multiplying your unit rate is going to come in handy. Okay, so let's look at this first one here. I have 3 units, right? I don't know what these 3 diamonds represent, but I know there's 3 of them. And I have money, so that tells me money is going to go on top. Okay, I have 28.35 over 3. I need to find my unit rate, so I'm doing 28.35, and I'm dividing it by 3. When I do that, I get $9.45. Okay, now before I take this $9.45 and I multiply it by these 4 dots that I have here, I want to double check and make sure that this second piece of data here gives me the same unit rate, just to double check. So 47.25 over 1, 2, 3, 4, 5. So 47.25 divided by 5. And I do. I get 9.45. So what I'm going to do to figure out what this M is here, I'm going to take 9.45 and I'm going to multiply it by 1, 2, 3, 4 diamonds. So if I take 9.45 times 4, I get $37.80. Okay, so that means that M is equal to $37.80. Okay, remember, you can take your unit rate and multiply it by your X to get your Y. Okay, so it's important to remember that you have Y over X. Money goes on top, so that means that our money is our Y. So this is our Y, and all these diamonds represent our X. Okay, we'll do another one. Here I have, what is the value of A? So I have these 4 circles and A, and then I have these 7 circles and $10.15. So I'm going to do $10.15 on top. Remember, money always goes on top, over 7. So I have 10.15 divided by 7. This gives me $1.45. Since I have 4 dots here, 1, 2, 3, 4, I'm going to take 145 and multiply it by my 4 circles. Okay, so 1.45 times 4, and that tells me that this is $5.80. So that means that A is equal to $5.80. Okay, so the biggest pattern with any of these type of problems is that you're finding your unit rate first. Okay, find your unit rate first, use your unit rate to solve the other problems, the other parts. Third letter of the quiz code is I as in island. I as in island. So you should have CHI. Okay. Here we have a what is the better deal? Or in this case, who runs more miles per day, Jim or Jamal? So we have a diagram for Jim and then a table for Jamal. We're going to do the same process for both of these. Okay, so I'm going to pick this portion of my diagram to figure out how many miles Jim runs per day. Okay, remember this is my X, this is my Y. Okay, remember X is always on top. It always comes first. So on this table, I read this side first. This is my X, this is my Y. So he runs 17.2 miles every 1, 2, 3, 4 days. I know it's days because my problem tells me per day. So if I take 17.2 and I divide it by 4, I get 4.3. So he runs 4.3 miles per day. Now when I look, that's for Jim. For Jamal, I'm going to choose this first one because my numbers are smaller. Right, I have 5, 27.5. This is my X, this is my Y. So 27.5 all over 5. Divide that on your calculator. 27.5 divided by 5. You get here 5.5 miles per 1 day. So if I'm comparing the data to see, if I'm comparing the data to see who runs more miles, right? Jim runs 4.3 and Jamal runs 5.5. So that means that Jamal runs more miles per day. Okay. Here we're going to find the missing value of a table. Okay, before we were finding missing values of diagrams, now let's find missing value of this table. So let's take this first one up here. Okay, I have 2, 12. So 2, 12. I have my y over x, so I have 12 over 2. Okay, 12 over 2. When I divide that, I get 6. Okay, so remember, you take your unit rate. My 6 is my unit rate, and I'm going to multiply it by my x. Remember, this is your x, this is your y. So I have 8 times 6. 8 times 6 is 48, which means that x is equal to $48. All right. So anytime you have your unit rate, multiply it to your x, and you get your y. Fourth letter of the quiz code is L as in llama. L as in llama. So you should have CHIL. All right. Success criteria. Can you determine unit rates from diagrams or tables? Can you determine if a relationship is proportional or not? Remember, for it to be proportional, it needs to have the same unit rate. Okay, all of them have to have the same unit rate. You have to check every single pair. Can I use the unit rate to find missing values? And can I determine which is a better deal from diagrams or tables? Hopefully those are all yeses. Last letter of the quiz code is I as in ice cream. I as in ice cream. Oops. So your quiz code should be chili, CHILI. And make sure that you go and take your quiz. Quizzes are 15% of your grade, so don't forget about those. If you have questions on any of this, please email me or message me, and I'll help you out. I will see you guys next week. Bye.